Good morning, and welcome to the first of three videos on section 12.1 in your textbook entitled An Introduction to Limits. All right, now chapter 12 is an introduction to calculus in and of itself. All right, this is why we call the course Precalculus, and some of you in the fall will continue this course for a full semester, and others will start with Precalculus, which covers more of the stuff that you would find in the textbook that we are currently using. In any event, some of you may have looked at limits at least a little bit in high school. To others of you, this may be completely new information. So don't be afraid to ask questions. Send me an email. We can have a private Zoom or whatever is required in order to get this information to you so that you understand it. All right, so the way that we're going to introduce limits to you is starting with an example. All right, and I'm going to ask you to find the dimensions of a rectangle that has a perimeter of 24 inches and a maximum area. Now, first and foremost, all right, if you look at a rectangle, all right, we know it's got four sides. All right, it's got two lengths that we call W for width and two that we call L for length. All right, and so in this case, I know that the formula for perimeter is equal to 2 times W plus 2 times L. And in this particular example, that gives me 24. All right. So perimeter is equal to 2W plus 2L. That's not 21. That's an L equals 24. All right. Which means if I divide everything, each term by 2, W plus L equals 12. All right, let me make that an L. And so L then is going to be, if I subtract W from both sides, L is going to equal 12 minus W. Now, the formula for the area of a rectangle is L times W, right? Length times width. Well, I just figured out that my length is 12 minus W, so that's going to go here times W. Excuse me. And if I distribute the W term, W times 12 is 12W, and W times W is W squared. And so the formula for the area of this rectangle, the area inside this rectangle with a perimeter of 24, is going to be 12W minus W squared. Everybody following along with that? At least I hope that you are. Now, how exactly would I then go about trying to find the maximum value for the area? Well, it may the easiest way is to calculate the limit as such. Now, how do we do this? Well, first of all, right off the bat, from your geometry classes, you should know that the rectangle that has the maximum internal area is a square. All right, and so if my square has a width and a length that are equal to one another, 24 divided by 4 sides is 6. And so the width is going to equal 6 and the length is going to equal 6. All right, that's something that in theory you should know from geometry. All right, if you want to build a pen, a field, whatever, and have the maximum area with the smallest possible sides, you build it in a square shape. Now, so if my width value is 6, all right, and I'm going to use the formula for area as 12w minus w squared, then what I can do here is build myself a limit table where I put width in one row here and area in the other row here. Now, I know for a fact that if the width of a square is 6, then the area of that square is going to be 36. And so what I do here on either side is moving this way, I decrease the value of 6 by a tenth, and then by a half, and then by 1. Going toward the right, I increase the value of the limit by 0.1 or tenth, then a half, and then by 1. And if you look at the calculations that we do here using the formula 12w minus w squared, notice that the maximum area value is with a width of 6, and when I go down or up, I decrease the value of the area. All right. With a width of 6, I get the maximum area of 36. With a width of 5, I go down to an area of 35. And with a width of 7, I go down to an area of 35 as well. And so what that means is that the limit of A for area as W for width approaches 6 is 36. Written in limit notation, that would be the limit as W approaches 6 of A is the same as the limit as W approaches 6 of 12w minus w squared, which I know is 36. Excuse me. All right. So what is the definition of a limit? Okay, well, sorry, my allergies are killing me today. The definition of a limit, L, at a number A is written as this, all right? This is the limit notation that you see here. And the way that you read this is the limit as x approaches A of f of x equals L. Okay, let me say that again. The limit as x approaches A of f of x equals L. Okay, so the L stands for the limit. What that means is that as f of x gets arbitrarily close to this value L, as x gets arbitrarily close to, but not equal to A. All right, so as x gets closer and closer to A, f of x gets closer and closer to L. All right, that's what a limit means. That's what it means to calculate a limit. All right, as x gets closer and closer to A, by the way, from both the positive and the negative side, f of x gets closer and closer and closer to L, the limit. Okay, so that's where we come from, or come at that from. Okay, so what exactly does that mean? So let's look at another example in order to figure out what we can do with this kind of information. So example number 2 asks you to use a table to estimate numerically the limit of, as x approaches 2, of the formula 3x minus 2. All right, once again, the limit as x approaches 2 of 3x minus 2. All right, so what are we going to do here? Well, again, we're going to start by building ourselves a table, all right? And the values of x will go in the top column, and the values of top row, and the values of f of x, which is 3x minus 2, will go in the bottom row. Now, the value in the middle is going to be 2, right? Because this is as x approaches 2, therefore the 2 goes in this value of x. Notice that in this case, I have then decreased the value of 2 by 1/1000th, by 1/100th, and by 1/10th. On the right-hand side of the table, I increased the value of 2 by 1/1000th, 1/100th, and 1/10th. So now I go through these values and see what I come up with. All right. Now take a minute or two. Take out your magic number box and plug in 1.9 for x. So 3 times 1.9 equals 5.7 minus 2 equals 3.7. So when x is 1.9, f of x is 3.7. 3 times 1.99 equals 5.97 minus 2 equals 3.97. Okay. 3 times 1.999 equals 5.997 minus 2 is 3.997. Now, if you look very carefully, you can see that these numbers are now getting closer and closer to a value of 4. Right? And you would expect that because 3 times 2 is 6, minus 2 is 4. However, let's move ahead to the 2.001. So 3 times 2.001 equals 6.003 minus 2 is 4.003. Darn close to 4. 3 times 2.01 equals 6.03 minus 2 is 4.03. Come on. And guess what? 2.1 times 3 equals 6.3 minus 2 is 4.3. All right, and you notice that as I move toward the left from the rightmost end, I get closer and closer to 4. As I move toward the right from the leftmost end, I get closer and closer to 4. So what's the value here? Well, L should equal a value of 4. Now in this particular case, it actually works out because if I plug in 2 for x, I get 4 right there. So that is my limit. All right, and that's shown again in this this table. All right, if the limit is unknown, all right, you can see you're getting closer and closer to the value of 4 from both the right and the left. All right, and so as x approaches 2, the limit is 4. Okay, at least for this particular example. Now, why don't I just plug in the 4? Why don't I just say, well, 3 times 2 is 6, minus 2 is 4? The answer there is that you won't always be able to calculate a defined term for a limit. And that's why we calculate limits using a table like this. All right, let's have another look that will kind of illustrate this example a little bit more, what I'm trying to show you a little bit more accurately. All right, in this particular case, it asks you to use a table to estimate numerically the limit as x approaches 0 of x divided by the square root of x plus 1 minus 1. Now, excuse me. The square root sign only goes over the x plus 1. Oh, sorry. All right, so use a table to estimate numerically the limit of x as x approaches 1.
It's 11 o'clock.
Thank you, Jesus. The limit as x approaches 0 of x divided by the square root of x plus 1 minus 1. All right, so how do we do this? Well, let's try to cheat and go right to the middle, because that'll give me the answer right off the bat, right? So if I plug in a 0 here, 0 plus 1 is 1. The square root of 1 is 1. 1 minus 1 is 0. 0 over 0 is undefined. All right, and so what's the limit? Well, there's no way to figure that out just by direct substitution. So what I'm going to do is I'm going to decrease the value of 0 by 1/10,000th, 1/1000th, and 1/100th. And then I'm going to increase the value by 1/1000th, 1/10,000th, 1/1000th, and 1/100th. All right, so let's do a little bit of math here. All right, so if I plug in negative 0.01 for this, I get 0.99. All right, the square root of 0.99 minus 1, and then, come on, x divided by that is going to give me 1.99499, according to my calculator. Okay. If I plug in negative 0.001 here, I end up with 1.99950. Oops, I missed a 9. There should be another 9 in there. All right, 1.99950. If I plug in negative 0.0001, I get 1.99995. Okay, so obviously I'm approaching a value of positive 2 here. Let's do the same thing on the other side. 0.001, 0.001, square root, minus 1, 0.0001, divided by that is, okay, that gives me 2.00040 zeros with a 5. Okay, and if I plug in 0.001, I should get 3 zeros, so 2.00050. And if I plug in 0.01, I get 2.00. Okay, and that gives me 2.00499. Okay, but again, looking at this from both directions, I'm getting closer and closer and closer to a limit of 2. Now, this limit doesn't really exist, because if I plug in 0 as a value of x, I get f of x is an undefined term. But you can see that approaching from the left and the right, I get closer and closer and closer to 2. And that means that the limit here equals 2. Okay. All right, and so this is the data from that this calculation. Okay. All right. So that's where we are at that. Okay. All right. So, any questions about this right here? Okay. If you do, send me an email or ask for a Zoom meeting or whatever you need to do. But this is how we calculate a limit using a table. Okay. Now, we'll do some more examples in the next video. So I hope that was helpful, and I hope that you learned something.